I welcome you to the series Python Made Easy for Beginners. This is the sixth tutorial in the series. The topic for today is function. As at the end of this tutorial, you should be able to define and call functions. A function is a block of code that can be called to perform a specific task. It is a self-contained program that is designed for carrying out a specific task. It helps us to avoid repetition because you define it once and call it many times. Generally, programmers hate repetitive tasks. Human beings invented computers to carry out repetitive tasks. So a function is one of the ways of avoiding repetition on the part of programmers. It is also a step towards code reusability. So creating a function helps you to create concise programs. A function is a small self-contained program. You can include it in a larger program. You can call it anywhere in your larger program. When you do this, you do away with the tedious task and error-prone task of repeating a bunch of statements. One of the ways of explaining function is to look at some examples. So we'll look at examples. In order to create a function, you have to define it. You use the keyword def, which is short for define. So def. And then the name of your function, in this case my name. You put a colon. This is the function heading. Now the body of the function, that's a list of statements that should be executed by the function. So in this case, this is a very simple function. Print my name is. So this is how a function is defined. Now you call a function by typing the name. So this is here. What I'm doing here is calling the function. Call or invoke the function. Invoke the function. Call the function. So let's run this. So it prints my name is Dan. Now we can include a variable here. Now this is called a parameter. A parameter is a variable enclosed within quotation marks when a function is defined. If you have a parameter, then you can pass an argument to the function. An argument is the data that you give to a function in order to carry its task. So I'm modifying this program now. So let me have welcome. Alright. So when I call this function now, I have to provide an argument. The first one did not require an argument because there was no parameter. So in this case now, I must provide an argument. So we'll now run the program again. and we have welcome done. So that's a function definition. Let's take another example. This same program can be, of course, modified if you want to use formatting. You can modify this. Let me modify this. You can have print, and then, so if you want to format this, my name is, okay, and then here you put okay. So that's another way of, it's basically the same thing. Just wanted to show you another way. Again, you call the function by typing the name of the function and then providing an argument, mark, for example. So this is another thing you can do. So if you run this program again, this argument will be passed to this variable. It will be assigned to this variable. So let's look at it. So my name is Mark. So that's that. Now let's look at another example. Def add numbers. So again, the function is defined using the keyword def. That's short for definition. The name of the function is add numbers, and then this function will have two parameters, x and y, and then we'll say return x. So this function will return a value where it is called. So x plus y. Okay, now I'm going to call the function, so I'm going to create a variable called sum underscore num. Okay, then I'm going to call the function here. You see, I have, since there are two parameters, I must provide two arguments. So two arguments. Now these are what we call positional arguments. 9 will be assigned to x, 4 will be assigned to y. Okay, if you put 4 here, it means that 4 will be assigned to x and then to y. So the position matters in this case. So now print sum num, sum underscore num. So this function returns the value. So when you run the program, you have 13. Okay, so that is for position. Now if you try to run this program with one argument, you will get an error. Okay, you see, you get an error because you have a positional argument here. So if you have 3 parameters, you must provide 3 arguments. So if you do that, you will have this error here. That's positional argument y is actually missing. So the program will not be executed. There's also something called keyword arguments. I told you that if you are using positional arguments, that the order of the arguments matters. Now if you don't want it to matter, what we can do is actually we can say here y equals, or y is assigned or is set to the value of 4, and x is set to the value of 7. So if you are using keyword arguments, then the order of the arguments doesn't matter anymore. You see, in this case, y comes first because I'm using keyword arguments. If I were using positional arguments, I will have to, the value for x will come first. So that is another point to note. So as usual, if you run this program, you get 11. That is keyword arguments. In keyword arguments, the order of the arguments doesn't matter. Let's look at another example of keyword arguments here. So keyword arguments. So we have a function def, again, my score, and in parentheses there are, it has 3 parameters: math, biology, and then chemistry. Let me just use lowercase for this. Doesn't matter, but just want to do it that way. Okay, as usual, you have a colon, then the body of the argument is print, that's for displaying the value to the screen. My score in chemistry is, all right, plus, I'll come back to it. We'll get an error if we leave this like this. And then you now calling the function. Call the function. So you have my score. That's keyword argument. So since we are using keyword argument, the order doesn't matter. You can have chemistry can come first, math can come later, next, and then biology. Okay, now if we run this program, we are going to get an error because there's going to be a type mismatch. So to solve that problem, what I'm saying is that you cannot add an integer to a string here. So this will lead to an error. So to solve that problem, we do type conversion using str, str, okay, so that the integer can be converted to a string, and then we'll not get an error. So let's run the program now. So my score in chemistry is 70, so it works. So the next example is something called arbitrary arguments. Arbitrary arguments. That's another thing you also use when you are creating function. Arbitrary arguments, which is usually abbreviated as * args. So you have, again, function definition def, my friends, for example. So the name of the function is my friends. So an arbitrary argument, we use this when we don't know the number of arguments that will be provided when a function is called. So we put asterisks here, and then we'll include the parameter there. So that's the key word, having asterisk, because we don't know the number of arguments that will be passed to the function. So the body of the function, you have print my best friend is, and then so I'm now calling friends here. Now what happens here is that when you provide these arguments, they are passed to the function in the form of a tuple, and since they are passed in the form of a tuple, you can actually select one of them. So you can access them using the same way we access a list, using the index. So I'm going to have one, that's index 1. So now I'll call the function here my friends. So I'm going to now provide the arguments here: John, Dan, Mark. So when I run this program, this is at index position 0, this one is at index position 1. So when I run this program, it will bring my best friend is Dan. You can include another argument. So these arguments are passed to the function as a tuple. Then so that's the case of arbitrary number of arguments. We don't know the number of arguments that will be provided when the program is executed. There's also something called arbitrary number of keyword arguments. Arbitrary keyword arguments. Okay, it's very related. Keyword arguments are very related to this as well. In this case, it is abbreviated as double asterisk packs. Okay, that's, if you see this, they are talking about keyword arguments. So let's use another example again. So a function, we define a function called def our friends. That's the name of the function. And then in parentheses, this is where we don't know the number of keyword arguments that we passed. So we put that in parentheses. And then we'll now, let's say, print he is from, okay, just like we did before, we make a reference to we'll use, in this case we'll have guys. Okay, that's the name of the, okay, sorry, okay, let me use city. Actually, let me change this to the variable, the parameter here to guys. Then I will now call here guys. Okay, then as I said earlier, the arguments will be passed to the function as tuple. That means we can actually make selection, use the index to pick the one we want. So we use the square brackets here, and in this case I'm going to have city, okay, and then of course I need to close this. So I'll call the arguments, the function now are friends. So I'll call the function and I'll have city, I'll have Cairo, for example. So we don't know the number of keyword arguments that will be used. So that's why we use keyword arguments. Let's say we have Dallas, and then another one, city 3, and let's say we have Lagos. Okay, so that's how to use keyword arguments. Let's run the program. So when I run it now, this is, it will display this. He is from Cairo. That's arbitrary keyword arguments. So you can add another city and it wouldn't change anything. Okay, you can say city 4, city 4, maybe let's say you want to let's say you want to say Alexandria. Okay, so if you run the program, you will say get Cairo because of reference to this. That's arbitrary keyword arguments. The next thing we are going to look at is the concept of local versus global variables. When you are creating a function, you use a bunch of variables, and variables will help you to avoid this repetition, which is the purpose for creating functions. Now, local, there's something, a special kind of variable called local variable, and then of course there's another one called global variable. We've been using global variable in most of the programs we've been writing so far. So in functions. So let's say we have a variable called a variable s that has the value 7, and then under here we define a function. Let's call it demo function, and of course this function is not taking an argument. There is no parameter there. So we now, inside this function, we'll define another variable. We define variable x again and give it a value 9. So this function here is a local variable. This one is a global variable. So now let's say print, you will see in demo function x equals, and then so that's the value in demo function, the value of x. Now we now call the function here, we say demo function, and then down here we will do print x equals So let's run the program, and then you'll see what will happen. In demo function, the value of x is 9. That's it. But when we executed this statement here, the value of x is 7. So what this means is that the global variable is only used in the function. After the function, it is discarded. So it has validity only in the function. In other words, it is overriding the global variable within the function. That is what is happening here. But outside the function, the global variable is still in use. And that's why you have 7 here. But within this function, only the global variable, the local variable hides the global variable. So you have to be careful when you are using global and local variables, because you may end up with the answer that you didn't expect. So this is a very important concept to also understand when creating functions. And then finally today we'll look at the concept of recursion. The concept of recursion. So recursion. This is another important concept in computer science. Now a recursion is basically a form of repetition. A recursive function is a function that calls itself repeatedly. Alright, that's what a recursive function. There are a bunch of them in computer science. For example, the acronym PHP means PHP means it means PHP hypertext preprocessor. Okay, so we are defining something in terms of itself is this is a recursive acronym, because we are defining the acronym in terms of itself. In order to say what PHP means, we refer back to PHP. Okay, so this only makes sense in computer science. In everyday life, people will not find this reasonable. So a recursive function is therefore a function that calls itself. So let's look at an example. The best example, I think, is using what we call factorial. Def factorial. So it takes, there's a parameter n, and then we'll say if n is less than or equal to 1, we'll say return 1. Okay, else we say return n. You see, we are calling a function within a function. So this function factorial is calling itself here. So that is the idea of recursion. So n minus 1. All right, now we will now call the function. All right, call the function. So the function is factorial. So we say actually, instead of, let's do print here. Print Okay, so then, for example, if I want to do 5 factorial, this is how to write factorial. Okay, 5 factorial equals, so I'm going to now call the function here factorial n. So the argument is 5, and of course we'll close it. So this is a very good example of recursive function. For those of you interested in the mathematics of this, the formula for factorial is n times, okay, n minus 1, okay, n minus 1 factorial. So if you say 5 factorial, you will now have 5 times, here you have 5 minus 1, okay, factorial. So this will now give you 5 times 4, 5 times 4 factorial, okay. You see, so you will now calculate 4 factorial, which is 4 times 4 minus 1 factorial. So that is the idea. Do it repeat. There's repetition here. You're doing something repetitively, okay. That's the idea of factorial. So that's how you keep on doing this. So your subsequent answer would depend on the previous answer. You know, you are building on something. So that is factorial. Let's run the program and then we'll see what it does. So look at it. The factorial of 5 is 120. So this is what we mean by factorial. This is cool, but it can also cause problems in your programs. You can end up with an infinite loop. Okay, so in some cases you may prefer to use while loop instead of using recursion, because a recursion can lead to an infinite loop. This has been Python Made Easy for Beginners. This tutorial is brought to you by ByteVista. ByteVista is an IT consulting firm. Our provinces include computer repair, computer networking, tutorials, data recovery, and for more information and from a list of other services we provide, you can visit our website. Our website is bytevista.com. That's it for today. Please, if you like our videos, share and like our videos on YouTube and every other platform where it appears. Till next tutorial. Goodbye for now.